Let's see the factors of internal resistance. We have already discussed what is internal resistance inside a battery or inside a cell. So this is a battery. This is plus side, this is negative side. So inside the battery also current will flow, okay, from one terminal to other terminal. So inside the battery also there is some resistance, small r. This is called internal resistance. Okay, if you connect from outside with the wire, current will flow from positive to negative side, but inside the battery current will flow from negative to positive. Current will flow. Okay, so inside the battery also there is resistance or internal resistance. Now what is the factor? Now factor number one. Okay, first factor is the surface area of electrodes. So I'm going to make now another symbol or another battery, ideal battery. So this is a battery. Okay, inside the battery one electrode is here and the electrode is here. Okay, so it is like a plates inside this battery. One is plus terminal and there is negative. Okay, now here now surface area of electrodes. First thing is surface or surface area of electrodes. This area of electrode is called surface area of electrode. Okay, if you increase the size of electrodes, now current will flow easily. Okay, so there is no greater resistance. That means now if you increase the surface area of this electrodes, these two plates are called electrodes inside the battery. Okay, increase the surface area, resistance will be decreases. Or if you write in the symbol, if you increase the area, okay, now the resistance will be inverse. Okay, if you increase the area, current will, resistance will be small. Or if there is very large resistance, internal resistance, that means this area will be very small. This area will be small. Okay, now surface area and internal resistance are inversely proportional to each other. When one increases, other will be decreases. Or from you can write down this way also. If you write down here in denominator area, so resistance will be off here now. Okay, so this resistance is inversely proportional to the surface area of electrode. Number two. Okay, what is the factor? Number two is the distance between the electrode. Now here is distance. These two electrodes are separated by some distance of this d. Okay, now if these two electrodes becomes very close or distance is very small, then resistance also will be very small. If they increase the distance of these two electrodes, resistance also will be increases. That's why the distance, okay, or distance of separations d. This is directly proportional to the inversely proportional to the internal resistance. Or if you increase the separations, okay, this resistance will also be increases. Clear? Sorry, this will directly proportional d. Okay, if you increase the distance, resistance also increases. That's why if these are very close to each other, if there is a small distance between these two electrodes, resistance also will be very small. Okay. Number three. Number three is nature and concentration of electrolyte. Number three is nature of electrolyte. Okay, electrolyte means this battery is may be filled of semi-fluid or liquids or acids, alkali, etc. Those fluids are called electrolytes. So different electrolyte has different resistance. Okay, if the electrolyte has more ions, the resistance will be small. Okay, or resistance will be proportional to the ions, or inverse proportional to the ions. Ions means there are different type of electrolytes. Okay? If you increase the number of ions, now it will decrease the resistance. If there is very small amount of ions, okay, or electrolyte is not good, then resistance will be very high. Number 4. Number 4 is temperature. Okay, temperature inside the battery or inside the electronic cell. If we increase the temperature T, resistance also increases, because increasing the temperature there will be more vibration. This vibration will disturb the flow of current. That's why there will be less resistance, or internal resistance will be increases when you increase the temperature. Okay, so these are the 4 factors which affect the internal resistance. Surface area of electrodes. Number 2, distance between 2 electrons or separation between 2 electrodes. Number 3, nature of electrolytes. Different electrolytes have different resistance. And number 4, temperature. If you increase the temperature, resistance also increases, or internal resistance also increases. These are the 4 factors of internal resistance.